NASA fired a spacecraft 7 million miles to smash into an asteroid 14,000 miles an hour in order to see if we could alter its course and save humanity when we do spot an asteroid on course to collide with Earth. And given that an asteroid flies past us closer than the moon every couple of years on average, and what's termed a near Earth asteroid zips past us every few days, it's an odds-on game that we've frankly been on a lucky streak for as long as humanity existed. For reference, there are more than 27,000 known near-Earth asteroids. The dinosaurs, of course, were wiped out 65 million years ago because they didn't have opposable thumbs, which means they couldn't build a space agency. That means that small mammals could thrive and live long enough to evolve and result in us. That was a lucky meteor strike for us, not for giant lizards. But if there had been another meteor impact during the last 65 million years, we, or our primitive ancestors, would have been wiped out before we had the chance to advance and build the great pillars of society: music, science, and critically in this case, space agencies. And that means that for the first time in human history, Earth history, there is a way to protect ourselves against an inbound asteroid or comet. Since the scientific revolution, we've hugely scaled back or eradicated the decimating effects of disease and child mortality, leaving only human-made disasters like war and climate change that could wipe us out. And that bolt out of the blue, the meteor strike. But after NASA impacted that 7 million mile away asteroid, telescopes and astronomers around the world eagerly watched to see if we could eradicate or mitigate that one remaining extinction event causing natural disaster. And we can now say with confidence that NASA's new planetary defense test actually worked. If you were following NASA's Double Asteroid Redirect mission, or DART, did you think it would work? Let me know in the comments below, because I have to admit I was 50-50. But DART was an unqualified success. In fact, it performed far better than we'd ever hoped, giving us confidence that if we saw an asteroid or comet heading straight for Earth, we could smash into it and knock it off course. Not in a Bruce Willis Armageddon style obliteration, because only an idiot would do that and risk Earth being hit with 1,000 pieces of giant space rock, like being blasted in the face with a shotgun, but nudging it delicately off course so that it sails past us without causing any problems, or as delicate as a metal projectile smashing into a giant space rock can be at 14,000 miles an hour. But the key thing is that we wanted to show that a small object could impart that huge forward momentum into an asteroid and change its trajectory without breaking it up and turning it into that life-ending shotgun blast. And since NASA's DART mission hit the small asteroid Dimorphos on the 26th of September, we've been waiting for the world's most powerful telescopes, including both the Hubble Space Telescope and the new James Webb Space Telescope, to gather weeks of data on its new course and tell us if it worked. It did. It really did. The target was actually a double asteroid system, as the name of the mission suggests, the Double Asteroid Redirect mission. There are two asteroids. Dimorphos has a diameter equal to around 6 railway carriages and orbits a larger asteroid called Didymos, which has a diameter equal to about 2 aircraft carriers. Dimorphos orbits Didymos once every 11 hours and 55 minutes, 1.2 kilometers apart. Or rather it did. NASA were hoping to hit Dimorphos with the DART spacecraft and slow its orbit by 10 minutes. This would show that it was possible to affect an asteroid's motion and deflect it from an Earth collision if it was intercepted early enough. If you were wondering why they were showing they could alter the speed of the asteroid rather than its direction, mathematically speaking, they're the same thing. If you hit an object head on, you slow it. If you hit it from the side, you change its directory. By speeding up or slowing down an orbiting object, it's easier to see and calculate the effect. Hence the astronomers eagerly observing the binary system for a solid 2 weeks after the impact. And the data showed better than expected results. Much better. Rather than slowing the orbit by 10 minutes, Dimorphos now orbits 32 minutes slower than it did. In this first ever attempt, and the first time humanity has ever tried to intentionally change the motion of a celestial object in space, humankind is now in the foothills of being a species that can save itself from an inbound asteroid. We're already very good at spotting new asteroids and comets that are large enough to give us a headache. As I mentioned earlier, we've catalogued over 27,000 of the bastards already. It's the smaller ones that we struggle with, but they're more of a risk to satellites and spacecraft than to life on Earth itself. They'll burn up in the atmosphere, or kill a cow in Kansas if fragments survive the fiery plunge through the atmosphere, missing the oceans that make up 70% of the Earth's surface. However, to be on the safe side, NASA is also launching a next-generation planetary defense space telescope in 2026 called the Near Earth Object Surveyor Space Telescope, or NEO-Surveyor. This will be a 20-inch infrared telescope able to detect not only bright asteroids, but also the harder to spot darker ones. After launch, NEO-Surveyor will begin a 5-year baseline survey to find at least 2/3 of the near-Earth objects that are out there, larger than 140 meters in diameter. These are the objects large enough to cause major regional damage in the event of an Earth impact. And as we know, NASA always exceeds its own expectations, so don't worry about the last third of near-Earth objects. I won't. And anything large enough to cause an extinction event should be easily seen. Beyond this, other missions are also in the planning to meet the US Congress's mandate to NASA to find more than 90% of all near-Earth objects larger than 140 meters in diameter. Now, the elephant in the room is still the time needed to reach an inbound space rock and how far out it needs to be in order to nudge it off course. If we used the DART impact on an actual inbound asteroid of a comparable size, it would have moved off course so little that we would still need to detect it and fire an impactor to hit it more than 25 years before its calculated Earth impact time. But this was only a small-scale test with a refrigerator-sized impactor weighing a little over half a ton. When we do detect an inbound space rock, DART has shown that we can now send an impactor to that asteroid and accurately hit it. And crucially, we have larger rockets than the SpaceX Falcon 9 that launched DART so that we can send a much heavier impactor. Remember, the mass and speed of the impactor determines how much we can alter the course of the asteroid. And with good space surveillance, we can spot them early enough to buy us more time to get an impactor out there. So with the SLS Moon rocket about to go on its maiden flight, we could send a much larger impactor. The Orion capsule that sits on top of the SLS weighs 50 times more than the DART impactor. Although that's designed to carry people to the moon, we could slam that into an asteroid to give us a much bigger nudge. If SpaceX get their Starship operational, the whole ship could be used as an impactor, 180 times heavier than the DART mission. So we have options. And this is all proven by the $324 million DART mission. For comparison, a single launch of the SLS will cost 12 times that much. So DART seems an absolute steal when you consider that it has shown that we could, for the first time in human history, protect ourselves against a life-ending asteroid strike that sooner or later will come. NASA Administrator Bill Nelson said, "All of us have a responsibility to protect our home planet. After all, it's the only one we have." This mission shows that NASA is trying to be ready for whatever the universe throws at us. This is a watershed moment for planetary defense and all of humanity. So what do you think? Does this show a mission to deflect an asteroid is now possible? Do we have the hardware? Will we spot them in time to do anything? Let me know what you think in the comments below. We reply to every sane comment, and I'd love to hear what you think. Oh, and don't f*** off just yet. If you want to know more about the realities of a potential asteroid or comet strike, here's a couple of videos you have to take a look at. Go on, you know you want to.